Class, let's be absolutely clear. Gravity is the fundamental universal force of attraction. It provides a constant downwards acceleration of 9.8 metres per second squared that acts upon all mass in all environments. It is the glue of our reality. Any questions?
Yes, Mrs. Global, I've got a question. If gravity acts on all mass equally, why does a balloon filled with air fall, but a balloon of the exact same size filled with helium ignores gravity and floats up to the ceiling?
It does not ignore it, Natalie. This is basic fluid dynamics. The helium inside the balloon is less dense than the volume of atmospheric air it displaces. Therefore, the upward buoyant force overpowers the downward gravitational pull. Gravity is still actively pulling on the helium atoms.
So the medium dictates the movement then? Does that apply to water too? Because an egg sinks in fresh water, but it floats in salt water.
Naturally, because adding salt increases the density of the water. When the fluid's density surpasses the object's density, the upward force wins. But gravity is still what gives the egg its weight to begin with. The 9.8 metres per second squared is a permanent fixture, Natalie.
A pound of wood floats, a pound of steel sinks. Exact same mass. Where's the constant pull?
The steel is simply more compact, so it displaces less fluid. You're confusing buoyancy with the fundamental force of attraction. If we placed that steel and your helium balloon into a vacuum chamber, they would all fall down to the floor at the exact same rate. That proves gravity.
But a vacuum chamber just removes the air. It doesn't remove gravity, because how can gravity be removed? How can you remove something that you can't detect or isolate? When you remove the medium, which in this instance is air, all objects fall at the same rate because they're simply denser than the void. The mass of those objects didn't change because the air was removed.
It's the equivalence principle. Gravity accelerates all mass equally.
Gravity is nothing more than relative density, Mrs. Global. If something is more dense than its surrounding medium, it falls. If it's less dense, it rises. And that rule applies to all mediums and all matter. Name something on Earth that breaks the rule of relative density. Give me just one example of something more dense than its medium that rises, or something less dense that falls.
Well, you have to look at the bigger picture. In the vacuum of outer space, where there is no medium, gravity is absolutely essential. The 9.8 metres per second squared calculation is how we understand gravitational fields and planetary orbits.
I specifically said on Earth. Outer space is not relevant, because even if such a place does exist, you'll never go there, will you? I'll never go there. So if relative density perfectly explains every single reaction here in the real world, why do we have to calculate for the vacuum of space when we're here on Earth?
Have a great weekend, everyone, and I'll see you Monday. Well done, class.
Saved by the bell, Mrs. Globell. Have a good weekend.